Find all complex solutions to z squared equals to negative 2 plus 2 root 3i. Then simplify the result into a plus bi form. So the plan in here is that, first of all, well, let's just copy that a problem. So the problem is that we have z squared equals to the real part, negative 2, and then the imaginary part, 2 root 3, attached by I, right? So the plan in here is that, first of all, we would try to get the radius r and the angle theta to represent the polar form of the complex number on the right hand side in here. And after that, we will take the square root of both sides so that we get the value of the complex number z, right? And this one, the problem is asking for all complex solutions. And because the problem, it gives us z squared, so that means that we should expect for 2 solutions of z. So then we're going to get z1 and z2 later, okay? So first thing first, what we're going to do in here is that imagine you have x in here for the real part. The negative 2 would be the x. And then the imaginary part, y, it would be 2 root 3, right? So first thing first, let's get the radius out of this. So the radius squared, we have the formula for it. It equals to x squared plus y squared. And let's plug them in, right? So the x in here, I would have negative 2 in red, plus the y in here is in blue, 2 root 3 all together, square. Right, and then this step in here, you can just put all of them into the calculator, and then you're gonna get r squared to be 16. And as usual, at this step in here, you don't want the r squared. You only want r on its own. So we will take the square root of both sides, right? And after that, you're gonna get r equals to 4. Okay, so now we got that radius already. So the last thing we have to find here is the theta. And we always have 2 formulas in a pair, right? If this one is the first formula of that pair, the second formula of that pair would be tangent of theta equals to y over x. And the y value in here would be in blue, which is 2 root 3. And then the x in here, it would be negative 2 in red, right? If you want to, you can cancel the 2's in here, right? Because, well, we can just cancel the 2 before we plug it back into the calculator, right? And then if you want to, you can go further and have it equal to negative root 3, right? After you simplify it, right? And then we need a calculator, right? So then all you would do for the step in here is that you would inverse it inside out. So the angle theta, it would be equal to tangent inverse of negative root 3. And then if you put all that into the calculator, you would get negative 60 degrees or negative pi over 3 if you're in a radian mode, right? So let's just keep it radian, negative pi over 3. Okay, how do you know if this one is the real angle or a fake angle? Well, let's graph it, right? Let's graph the original point that we're having. So from the problem, we have a negative x and a positive y. So negative x, so on the left-hand side of the x in here, and positive y. So it should be up there somewhere in the second quadrant, right? So second quadrant, I would say is like right here. You can just make a random point. It doesn't really matter where it is. As long as you know that it should be on the second quadrant, then you'll be safe. Well, if you take a look at the angle in cyan that we have in here, this angle, if you plot it out, if you draw it out, it would be in quadrant 4. And it would not match with the black drawing that we just had, right? Because our angle, it should be something in quadrant 2. But the blue one, the cyan one, it's not. It's in quadrant 4. So what we're going to do to bring it back to quadrant 2 is that we're going to add pi to it, right? So in the calculator, if you can do negative 1 over 3 plus 1, it would give you 2 pi over 3. And guess what? This one, it should be something in quadrant 2, right? And then we have a match in here. We have a good match in here, right? FYI, 2 pi over 3, it would be 120 degrees, right? So 120 degree is a perfect angle in the second quadrant. So you know that we're in the right shape for the angle theta. So after this, what you need to do is that you're going to rewrite the left-hand side of the original problem. So z squared equals, instead of going here, right? Originally, we have negative 2 plus 2 root 3 I right, originally. Now we're going to use the formula r e to the I theta, right? We know that r equals to 4 from above. And then back to the formula, we have e to the I, and then the angle in here, which is figure, it is 2 pi over 3, right? So 2 pi over 3, let me switch it to also cyan color. Okay, so now what, right? So now what? We're going to take the square root, right? So I'm going to switch it to blue, or let me do green for this one. So Z1, right? Z1, what we're going to do in here is that we're going to split the number part out from the E part. So we have 4 and we have e to the I angle, right? So split the 4 out of everything else, and we're going to get something like this. Right, we know that square root of 4 is a 2, right? For the other part, let's do e to the I 2 pi over 3 times a half. And this half is coming from the square root, okay? So let me change the square root to be purple. So you know that this is how we had the 1/2 on the other side. Okay? And then after that, well, let's simplify it further, right? So we're going to get 2 and then e, I, and then the new angle in here, it would be in a calculator, it's going to give you pi over 3. Okay? So, well, let's do it out, right? So this whole thing in here, what does it mean is that you're going to use the Euler's formula for it, and you're going to get it equals to 2, or r, right? And then cosine of the angle, which is pi over 3, plus I, and an r again, which is 2, and a sine of the angle, which is pi over 3. And then this step in here, what you're going to do is that you're going to look into the unit circle, right? So cosine of 60 degrees of pi over 3, it would be a half. And sine of pi over 3, or sine of 60 degrees, it would be square root of 3 over 2. Right? So what we're going to do in here is that we're going to multiply the 2 in front with this, and then you're going to get 1. Right? And then moving on, we're going to do the same thing. You're going to multiply this 2 by this fraction, and that would give you square root of 3 because the 2 are canceled out. And then you're going to rewrite a I afterward. Okay, let me make a better I in here. So that would be the first solution. Let me box it. And then like what we discussed at the beginning of the problem, we have z squared, right, from the beginning of the problem. So there should be 2 solutions, right? So how do we figure out the second angle, right? If you think about it, we have 360 degrees in a circle, right? So let's draw a circle with 360 degrees on it, right? And then if we have 2 solutions in here, that means they are 360 over 2 apart from each other, right? So that means that they are 180 apart from each other in degrees. And if you convert it to radians, they would be pi apart from each other, right? So if the first angle, let's do it in cyan again. If the first angle that we're having in here, it is pi over 3, right? It's pi over 3 for 60 degrees. So it's going to be in here. Pi over 3 is the first angle that we have. The second angle, it would have to be pi over 3 plus pi, right? Because they are pi apart from each other. So in a calculator, if you want, you can put 1 over 3 plus 1, and you're going to get 4 pi over 3, which is down here, across from it, from the origin. This is 4 pi over 3 for the second angle. Okay? So now let's write the solution for the second angle. We're going to go Z2 equals, the radius would be 2. And then E and an I, and a new angle in here, it would be 4 pi over 3. Okay, so we're doing everything the same at this step in here, but we're changing only the angle because they should be pi apart from each other for the square root. Okay, and let's plug back the Euler's formula. So we're going to go 2, or let me switch the line for this one. So we're going to do 2 and then cosine 4 pi over 3, and then plus I, and then the radius, the 2, and then sine of the same angle, 4 pi over 3. And then you're going to put it back into the calculator again. So cosine 4 pi over 3, cosine of 4 pi over 3. In the calculator, it should be negative a half, or if you want, you can also look at the unit circle. It's going to give you the same thing. For the other one, sine of 4 pi over 3, it would be negative root 3 over 2, right? You can always just check it. Okay, and after that, to get to the final answer, let's simplify it further. We're going to multiply this 2 by negative half, and it would give us negative 1, right? Because the 2 are canceled out. And then for the other one, you're going to do the same thing. This 2 would be canceled out with a 2 of this fraction, so then we would have negative root 3. And make sure you carry the I at last to show people that, well, the negative root 3 is the imaginary part. And that would be the second final answer. Okay.